chemical and ionic equilibrium relations in a single lecture. So basically equilibrium in water is equals to dx by dt. Forward reaction is equals to dx by dt for backward reaction. Second one, if for a reaction AA plus BB gives CC and DD, for this reaction dx by dt forward will be equal directly proportional to K forward concentration of A to the power small a and B to the power small b, that is the coefficients, and dx upon dt for backward reaction will directly proportional to K backward C to the power small c d to the power small d. And equilibrium constant, that is K, will be equals to products concentration, product of products concentration upon the concentration of reactants, that is equals to K forward upon K backward, that is equals to Kc. Now in terms of partial pressure, so for in terms of partial pressure the relation will be like this: Kp is equals to Pcc dot Pdd upon PAA dot PBB. This dot shows for multiplication, and Kp is equals to Kc RT delta Ng, where delta Ng is equals to number of products, moles of products minus number of moles of reactants. So these are the relations. And next is Van Hoff equation. So what is Van Hoff equation? Log 10 K2 upon K1 is equals to delta H naught, that is enthalpy change, upon 2.303 R. R is gas constant universal, and 1 upon T1 minus 1 upon T2. And then Gibbs free energy. So what is this? Delta G is equals to delta H minus T delta S. Delta G naught is equals to minus 2.303 RT log base 10 K, that is rate constant. Next, buffer. Now the relations for buffer are pH is equals to pKa plus log concentration of conjugate base upon concentration of their acid. Similarly, POH is equals to pKb plus log concentration of conjugate acid upon concentration of their base. And mixture of weak acids is equals to under root K1 concentration C1 plus K2 and C2. Next relation is alpha is equals to percentage conjugation upon 100. If for a reaction AX BY gives X A Y plus Y B X negative, KSP is equals to A to the power Y plus X B X Y Y. When AX BY, KSP is solubility product. Now, the next relation is for Arrhenius concept. So, what is this? Substances which give H positive ions when dissolved in water, while which substances which give H positive ions when dissolved in water are acids, while which give OH negative ions are called bases. Now, the next concept will be Bronsted-Lowry concept, which shows that acid donates proton while bases accepts proton. That's it. Next concept is Ostwald dilution law, which shows that alpha is equals to under root k upon c, where k is dissociation constant of weak electrolyte, c is concentration, alpha is degree of dissociation, Kw is H concentration and OH negative ion concentration. That is the ionic product of water. Now, next concept is hydrolysis constant, where Kh is equals to H square C upon 1 minus H. H is the amount of salt hydrolyzed and H is equals to Kh upon C under root is equals to Kw upon Kb into C. Now, strong acid plus weak base. For this combination, degree of hydrolysis, that is H is equals to under root Kw upon C Kb, and pH is equals to 1 by 2 pKw minus Kb minus log C. For strong base plus weak base combination, degree of hydrolysis, that is H is equals to Kw upon Cka is equals to pH is equals to 1 by 2 pKw plus pKa plus log C. So these are the relations. And for weak acids plus weak base, degree of hydrolysis, that is H is equals to Kw upon Ka into Kb, and pH is equals to 1 by 2 pKa plus pKw minus pKb. That's it. So these are the relations for equilibrium, ionic and chemical equilibrium. If you have any doubt, then please do in comment section. Thank you and have a nice day.